use the variables to take my terms and refine it this way. But not all over, just a little part of it. And look what happens here when I do this. I will do the blue one as the middle one of that one, the green one as the middle part of that one. So, but here I have an overlapping of the small right one from blue and the small left green from green. And because of the definition that I had and the dimensions that I have, when I add point to point, these two, I obtain this round, whatever. Now, the blue one was very L1, if L1 is the original. The green one is very Lj plus 1, if this is the other one. And the new one that I obtain, I can specify with the operation between this one and the other one. And I define something else between the start at the maximum of this and ending at the maximum of the other one. This is one point. Yeah, if I were to use the all over, so the whole rule base, that's what Adolfo Rodriguez de Soto does. You can choose the granularity that you need to solve your problem according to the requirements of the problem. This is okay. But you have to pay the price of increasing the number of linguistic terms, so you lose interpretability. What I wanted to do is to do a kind of a local multi-resolution, so to increase the resolution only in that part of the problem that I need, but I notice that my, let's say, approximation is giving me too weak results, then I need more terms, and I will do locally. If I do that locally, this is what I have, but now I have the problem to combine this right wing of the green triangle with the classical next linguistic term of the original linguistic variable. And if I do that, I obtain this monster. And the question is, what does this one mean? How do I know what this one means? I assume that I know the meaning of Lj, Lj plus 1, Lj plus 2, because those were the first linguistic terms I used. And I assume that the first thing that I do is I use my knowledge or some expert knowledge to obtain the first linguistic term. If I don't have that, forget it, it's nonsense. But if I have that, those are known. And the other I am beginning to know or to learn from the former ones. Now the question is, how do I get a meaning for this round thing? Well, if I look carefully what's inside of this one, I have three triangles. So this dotted black one, which happens to be very Lj plus 2. This kind of lila, which is now between the green and this black that I just defined. So this is between very Lj plus 1 and very Lj plus 2, which is this one. Now, this is the right wing of Lj plus 2, that's the main thing. And if I look at that, and what I have here, then I can define a new operation on words. This begins from this part, which I already defined, and goes to the right side of my original Lj2. So I am here using as objects of my computation words. And I define operations that I can apply on these words. So I'm doing computing with words, except that I didn't know that 4 years ago. Now, if however you are not computing with words, you are just specifying what has to be done. This is okay. I can compute once, but then I compute with numbers. From here to here, I change my context from computing with words to computing with numbers, because now I am measuring at every single point of my universe what is the value of this round function now. And it will be the value of this at the point u that I am solving, plus with the Tikhonov or Lukasiewicz. So I am looking for this one, which is the lila, plus Lukasiewicz, this pointed one in black plus the dashed one in black. If I add this with this one, I recover the slope of my original LJ2. That was the geometry which discussed later. And if I do a point-to-point, I will obtain this convex hull of the other sets. So here I am doing computing with words, here I am doing computing with numbers. If I want to know the value of this expression, let me put a u here at the end. This could be the way of computing with numbers the values corresponding to the choosing point. But here, I said this is consistent with the definition of Sare, of what is computing with words that I showed at the beginning. So what I had was a set of linguistical fuzzy sets, which I assumed they were known in their meaning. I did some partial refinements due to the requirements of the problem. From the initial linguistic sets, I hoped that with the use of the language, I was rounded up in the natural language, not in the meaning of these fuzzy sets. Probably the arrow should be the other way around. Now, come on. If ideally I would like to have some kind of semantics that would allow me to directly observe the modified linguistic sets and say, aha, this means that. But as I showed, I cannot, because I don't know the meaning of the non-symmetrical trapezium to represent the concept. However, what I did at that time, I called it metasemantic, was a way of relating the meaning of the new fuzzy set to the meaning that I knew of the former fuzzy set. That the mathematicians do to reduce the new problem to a problem whose solution they already know. And since these were already related to meaning in natural language because of the use of language, I could have a way of understanding. I'm careful, I'm not saying the meaning of what's here, but a way of understanding or finding the meaning for this thing here. Now, last year, Sare was here again and gave us a very nice talk with his name. He didn't mention computer words anymore. In my opinion, as the Germans say, he jumped over his shadow and spoke directly things by name. He had been trying to do processing with natural language right from the beginning, but now he says directly, computation with information described in natural language. This is the goal. Probably in his model, this is on top of computer with perception, whatever was the last of it here. Because this is a challenge. For this one, what we had to do is to develop a kind of compiler between natural language and the first programming language which you can think of, which is a very, very tough challenge. And for the sake of history, so this is not new, and I was not the only one who did this kind of things. Already in the 80s, early other people were doing natural language processing.